Okay, so now the question is asking to differentiate sin x with respect to cos x. Now we are going to deal with the parametric equations. Now how I knew that we are going to deal with the parametric equations and how you can learn about the parametric equation. First of all, we have discussed these parametric equation in our previous videos, so you can go and check out those videos if you're unsure about what the parametric equations are and how do they work and how they are solved. So you can watch those videos. But for now, how I recognize that this question is actually linked to the parametric equation and the chain rule. So if you see, we have sin x and then the cot x. The angles are same. You cannot differentiate sin x with respect to cot x. This thing is actually impossible. And whenever the question is asking you to differentiate the same variables, then it is actually saying you that move towards the chain rule method. Okay, so my first function would be sin x, then the second function g would be cot x. Okay, actually it is the third function because the second function is actually x in this question. So first of all, we have to know what the chain rule is. Dy by dx, we actually have to differentiate. This would be my y, this would be my g. What I want to find is the differential of sin x with respect to cos x. And I have made this function, this sin x equal to y and this cot x equal to g. So now the question is actually asking you, find dy by dg. Okay, so this is what would be the result of the product of the chain rules. Okay, so we have to find dy by dg, and how are we going to proceed with it? If you see, the first function would be the differential of dy with respect to dx, and the second function g by x would be the differential of dg by dx, right? If we take the differential of y with respect to x, it would be dy by dx. Okay, because the denominator has to be equal to the thing which is present on the left hand side, the numerator of the left hand side. Okay, so let me just clarify this thing. If you're having a function, for example fx, okay, let's just make a general function, and you're told that this function is actually equal to y, then if you're applying differential on both sides, dy by dx, you have to keep the denominator over here equal to the thing which is present in the numerator of the left hand side of the equation. Only then you are going to calculate your differential. Now for our case, we have y is equal to sin x. Now when I apply the differential on both sides, dy by d sin x, what is the thing which is present on the left hand side of the equation? What is the angle of the left hand side equation? It is x. So d by dx. And now I am actually able to find the differential of sin x. Okay, not a big deal. Now we have g is equal to cot x. Now again, I have to apply the differential on both sides of the equation. Dg by d would be equal to d by d. Now what is the angle on the numerator of the left hand side? It is x, right? So I have to differentiate it with respect to x. So d by dx, d by dx. Now this would be the second term of the product of the chain rule, and this would be the first term of the product of the chain rule. Cool. Now let me discuss the problem. We have the chain rule dy by dg, which is equal to dy by dx multiplied by dg by dx. The problem with the chain rule is, if you're having something over here in the denominator of the first product, you need to have the same thing in the numerator of this second product, which means that this thing should be written something like dy by dx multiplied by dx divided by dg. And that's actually very simple, you know. Why? Because after finding the differential of cot x, I would reciprocate it. Okay, so now the chain rule is satisfied and we know what are our equations, what are our variables. So now we can finally proceed by finding these two products. Okay, so first of all, dy by dx. So y is equal to sin x. Let's apply the differential on both sides of the equation. D by dx is equal to d by dx and sin x. Now the differential of sin x, of course everybody knows it is cos x, and the derivative of the angle d by dx, x, this would be cancelled, we get cos x. So this is the final dy by dx. Okay, then we have g, the function g, which is equal to cot x. Okay, so we have to apply the differential on both sides of the equation. Dg by dx would be equal to d by dx dot cot x. What would be the derivative of cot x? It is actually equal to negative cosecant square x. Okay, and the derivative of the angle, of course the angle is 1, so the angle is x, so the derivative of x would be 1. Okay, now let's see what the chain rule was saying. It was saying dy by dx, dy by dg, our second function was g. So dy by dg would be equal to dy by dx dot dx by dg. Now we are having dg by dx. Okay, so how I can reciprocate it? It would be dx by dg, and we will get 1 over cosecant squared x with a negative sign. Okay, so I hope that makes sense for all of you. Now let's just put the values. Dy by dx is cos x multiplied by, this would be negative 1 divided by cosecant squared x. Okay, cos x, the negative sign would be at the beginning, cos x, this cosecant x, of course if it is being reciprocated, 1 divided by cosecant x would be equal to sin x. So this is the final derivative of this question. Okay, so I hope that makes sense.